Assalamu alaikum wa rahmatullahi wa barakatuh. Hey guys, this is Abdul Azim Beg, and I'm going to show you the complete design and analysis and the modeling analysis and the design and the layout of the robot structural analysis. It has taken me about a year to understand the program, and I've seen the different tutorials. So without wasting the time, let's just get into the tutorial. So what the first thing we should know about we could not just get into the program and just start analyzing. We should just know the things about the design. It's actually civil engineering. So what is happening is here that we should firstly know the architectural plan of our building. So this is a three-story reinforced concrete commercial building, and which has 3 stories, and which is a very simpler model. So what actually happens is, we can see here, it is divided into one, two, three, and 1, 2, 3 sections. So in this way we can just design it, and we can analyze it, and we can just proceed, and we cannot go into complicated design purposes. So firstly, this is the ground floor plan. This is the first floor plan. So what is happening is, in the center of the building there is an opening, and these are shops, and this is the stairs. Okay, now the information about the building is most important. We should determine the preliminary design assumptions, and this is the main thing which people make mistakes about. The main important thing about the story height, we should just consider how much. The people sometimes consider that commercial building should not be less than 4 meters. The height of a single story should not be less than 4 meters. And so what I did was that the ground floor is 4 meters, and first and second floor is 4 meters also. The length of the building, the width of the building, and the height of the building is just determined. What we are going to do, the second thing, which is the most important thing, is that we should assume the initial sizes and specifications of the building according to ACI 318 code. So what's happening is, the first thing we should consider is columns, and the columns for the ground story from the ground floor, it has the greatest load, so it should be the greatest size. And as long as for every time we just increase the amount of loads, we should decrease the size of the columns. So the first assumption is that as long as we are going upwards in the building, the columns will be decreasing in the size. And the second assumption is that the exterior columns will be smaller than the interior columns, because the load of the building is always directed towards the center. So what I have done is that ground floor has 500 into 250 of exterior columns, and 600 into 250 millimeters of interior columns. Okay, so the first and the second story columns are of 400 into 250, and it's clear from here. So the beams for the tie beam, which is taking the whole load of all of the we can say the wall loads, the dead loads of which is actually a line load onto the beam, which is, so we can just take it about 250 into 600, and this is a constant. And same here, and for other for exterior ones, I have taken 25 into 40 and 25 into 50. So what happening is, if we are taking the smaller sections, then if it is wrong, the program will say the section does not reach the nominal capacity. So or it sometimes says errors. So we can just increase sections, and it will go on its way. Another important thing about is that in the design, the load is distributed by the concrete and by the reinforcement. So the concrete takes the partial load, and the reinforcement take the partial load. So we cannot say a small section will be a good section, or neither we can say a large section will be a good section. So it should be a balance. So we are going to start with the smaller sections, and if it doesn't goes fine with the design, then we can increase the size of the column, so with the reinforcement will increase. Okay, so the type of the beam to column connections is fixed, and the column to base connection is fixed. So without wasting the time, just some material properties. We are going to consider the 25 kilonewton per millimeter square, density of concrete 24, modulus of elasticity 21, and yield stress is 420. So and another thing, this is the second most important thing, is that we should know the dead and the live load of the building. So what we're going to take is the floor of the first and second story building will be of 1 kilonewton, and it is just a magnitude, and it is not the actual one. We are going to increase that up, and the surface is of magnitude of 2 kilonewton. So why is that? Because it is containing the isolations and the heat installations and the water insulation layers, which is on the top story, on the surface. Okay, so the complete self weight of the slab of 200 millimeter thickness will be, which it is just an assumption and just an assumption, so we are just going to take 4.2 kilonewton per meter square. And the line load of the exterior walls, which is of 0.25 thickness, a block of 20 into 40 centimeters, and is the standard one. But for this building we are going to use the 25 centimeter to 40 centimeter of a block, and its weight is multiplied by 4 meters. 4 meters is the height of the building, of height of a story, sorry, and 0.5 is the breadth of the block. And the 18, what is 18? The 18 is a unit weight of the concrete, of the unit weight of the material of the block. Okay, and then it comes out to be 19 point. So what is this? This is 0.02 is the layer of the iso of stuc, of paint and other layers, and which actually increases the amount of the load on it. So for interior walls we have 4 meters, 4 multiplied by 0.2 and multiplied by 18 by 8, and this 0.2 is the layer after the wall, which is the insulation and others other paint layers. Okay. So this is the most one of the most important things, that the denomination of the live load. It has been told in the ACI code according to the ASCE 705 section 4.9 page 12 table 4.1, that according to the type of the building we can assume the live loads. So the live load for balconies, for public, so what we're going to do is, okay, we can just go with I think so we can go for it with this table. I have another table in the end of this file. Okay, no, it's not here. All right, just a second. All right, so this is the minimum live load on the slabs, which is residential buildings have a 200 kilogram per meter square, residential balconies, computers. So the according to this table, which is according to the ACI code, according to this table we will fall in the category. This is commercial building, so we can just say during the analysis from we assume a uniformly distributed planar live load of 5 kN per meter square as the building falls in the wholesale store category. So wholesale category is just right here. I just cannot find it. Okay, this is 500. Okay, which means 5 kN per meter square. Okay, just land into the program. So for the program you should just have the access plan. The access plan is a very important thing. It just gives you the distance between the center of the column to the another center of the column, and actually it is the center of the beam also. So actually I have a column of 25 centimeter, so actually it will be better for me to just go that way. Okay, so just go here. The first thing here is we should go to window, tools, job preferences. Number first thing is we should go to units and metric. That is all units will be metric. The another thing which you should make sure about, that the design code is ACI 2002. That is fine, and loads okay, fine, that's fine. The reinforcing bars, there was a problem that it was not metric before. I had just completed into metric. And the modification, now this is very important thing, that while going into concrete we should just make a new concrete. We can just say it FC 25, and the young modulus, as we know, we have already told it is 21.5. Sure, just a second. Alright, so this is 21,500, and the Poisson ratio and the shear modulus we can just leave it as it is, because it is a very clear value. It's a near value. Actually there is a formula for it, so I'm just gonna complete it in the next tutorial. So we are just going for just a basically simple thing. So just we can leave it just 25 megapascal, and I think so that will be fine. So we can just add it up, and oh sorry, I think so FU20 is FU25. No, just give it here, FU25 and 21,000. Okay, we can just add it like this, and it's okay. That's good. Okay, now just another thing, just come here to the preferences and just come here and just make sure that your I think that will be fine. Okay, first thing first, how much is our section? We can just make it right here, and 6.5, 6.3, 6.5. okay, so I can just write here, I can just make here and add a 0, and then I have a distance of 6.3. I don't know, yeah, 6.3, 6.5. Yeah, that's right. Sorry, that's right, 6.5. okay, and then I have a distance of so what happens is I have to add it up. I can add 12.8, so that's it. And then after that I have 12.8 plus 6.5, I have 19.3. At 19.3. Okay, that is fine. I have 12.8, and that's good for X. Now I'm going for Y. So for Y I have I should start with here, not from here. So it is 2.6, then 4.7, 7.3 and 6.3. so it's very simple. I'm just gonna go here, and it will be 2.6, and now I should actually go with a 0.00 and then just enter it, and it's very simple. Just like that. Just a second. Okay, so after that 2.6, we have 4.7, so 2.6 plus 4.7 I have now, which is equal to 7.3. okay, now 7.3 plus 7.3 once more, so it will be 14.6. okay, and now after that I have to increase 6.3 in that, so I can just add 6.3 in that, so I will go 20.9, so it will be 20.9. that's okay. Now I can just make an just make sure it's ABC, and that's it. And another thing you should make sure is you should have the base of 0, and just make it apply and just make it close. So here we are. Okay, we have got a problem in here. So what it is that there is 19.3, we have complete of 19.3, so then we can add it up and we can just make it like this. So this is just perfect. We can just make a save of it. Just say dot. That's it. Okay, the reinforced concrete beam, first of all I can go with the reinforced concrete beam, and the section here is I'm not actually satisfied with it, so we can just go here and we can just add sections from here. So my sections are defined in this file, so I have to introduce all of these sections into the program. So first of all I have 500 into 250, so where's it? Okay, yeah, I have 500 to 50, so it is to be understand that it is actually against it, so we can just make it 250 to 500. okay, because my columns are in this direction, you can just see how it just has come here. All right, so it should just go with it, and I am okay with that. I'm just gonna get okay, add another section. Okay, that is what's left out here. Just come here. Okay, 600 into 250. Okay, 600. I'm sorry, I am in beams. I should be in columns. All right, columns, reinforced concrete columns. Just come here, and it will be 250 and 600, 500. Just we can add. Then I have 600. Just we can add, and 400. I have 400. Just we can add, and I have. Okay, I think that will be good. You can just go with that. Now 3 sections. So first of all, this is ground floor. So what I'm gonna do is I'm just not gonna place it here. I'm just gonna place it. Okay, I'm gonna place it here. That's fine. And just make sure that it is 60, and just go down by 60. So our ground floor columns, okay, whereas ground floor columns is about 250 into 500. The exterior ones and the interior ones are like this. Okay, so we can just go here, and 250 into 400. That's fine. Now 250 into 500 for the exterior ones. So I'm going to come here. This is simple. See, just click here and just make an enter, and just write 0.6. Okay, just in the beginning just make some problems. Now it's good. Alright, so my section, I just make one thing sure that I have the units and formats, that my sections definitions is dimensions are in millimeter. Alright, so I can just make it sure like that, and the exterior columns for the ground story columns is just like this. I am just gonna come here, make sure that it is 0, and I'm just put here. It just comes like this, simple as that. I'm gonna just columns like that. This is as simple. No, not here. Just exterior columns I'm talking about. So exterior columns are like this. Sorry, there's no column here. So column here. That is fine. And the interior columns are of 25 into 60, and so as simple as that. Okay, and just make sure about that. Just make okay, that is fine. And okay, now this is good for this. Now we can just make one thing. Now geometry, stories, okay, and define manually. So this is a 160. I actually don't have a problem with that, so you can just go with the 4.60, and you can just story number 2, story number 2, and I can just add 3 stories from above that. Just add like that. This 0.60, 1, 2, 3, 4. That's fine. Sure. This is a problem. There's a problem. I should be doing this. Yeah, that's fine. That's fine. And I can just go it like this, apply, and done. That's good. As you can see here, we have 3 stories. 1, 2, 3. Okay. Now what you're gonna do is just introduce the beams. The beams are very simple. Just like the columns. You can just go here, and you can just see the beams here. The beams we have all the time in 25, 16, 25, 4, and 25, 5. So actually, this is 4 sections we are going with.
Easy to चला लो.
25 by 400. I'm just gonna make an add. 25 by 500 add, and 25 by 600, and that could be an add, and that's fine. So for the ground story, we have the exteriors 25, 6, and 25. It's okay for the ground story. It's just okay. Okay. See, this is a problem. You should make sure that you are 0.6 level. You can just make beam like this, like this. You can actually make it drag one, it's just good like that. Okay, and that's good. And the interior ones are the same one. Something like that. You see? Simple. Okay, that's good. Now we have the 60 level, so we should place our new columns in here. Okay, so what's our new column? So okay, we have just make sure that what is our first story columns are about. Columns in the ground floor, first and second are 450, and the exterior ones 400 to 50. Okay, 400 to 50 the exterior ones. That's it. And the height is about 4 meters, so it's fine. And that's it. You can just go here, just put our columns. Yeah, and you can just write 4 meters in meter. Fine, and then I'm going to go with 200, 500, same thing. Just have to make sure one thing here that now that's good. We can just go into sign this. The sign is full of that. Okay, now what? Now comes the interesting part. Okay, no, it's not right now. This interesting part we have the beams of position 3 goes 2500. That's tier 1, and the tier 1 is 2500. Okay. Second 25 by 400. Okay. The beams are 25 by 400. Okay, so there's no way up right now. Just the beam from its lowest way. See, we can just make it up in a drag here. Just make it here like this, like this. Just make it like this here, and here, open the drag, and we'll just make it 25 right. So yeah, that's right. Okay. This one here. Okay, I just forgot something here. You should be doing this beam. There's a beam here. You should not forget it. Should not forget because okay, there's another problem here. That from second story the beam is not continuous, and you should be making this two different ways to do this because this is open now. You're gonna see this that this central portion is open. Okay. Now what you're gonna do is just the most noise part. I just know that just select this up, okay, and okay, and just go in this one. Just make this one. Okay, there's no translation. I just want to make a move and move thing is yeah, this is moving copy. Yeah. So okay, this new story. This story. Okay, and then sorry. Click here. Sorry, it's errors. Why it's not being this one? Okay, just click here. Then go this like rectangle. I don't know, it's not working. I think so. I have to select it once more, and just go here and click here. Maybe like this. Okay, what's happening? I don't know. I think the better way is just like this. It's not going that way, bro. Zero, 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 and just make it full. Just make it enter. That's right. Sometimes programs are just like that. Not sure about that. Okay, there was a problem. Oh my goodness, that's not good. I have to just go there. Avoid the slabs, man. You have to go for the slabs right now. Okay, this is different kinds of slabs for me before. We can just go for a solid slab, and solid slab we have considered it as 200 millimeter thickness and reduction of moment of inertia by 0.01, and we can just make a FU 20, and yeah, that's it. Just make it up 20. Just make it 20 to 200. Okay, solid slab 200, and we can add, and solid slab 200 gets here, and we can just make a rectangle. And okay, we can just go here and okay, just come here and just do the same thing, and right here same thing. Good. Do you have a problem here? I'm going to read this one. See, this is what I want, and yeah, this is like this, it's like here. And the best thing what we can do right now is we can just introduce the loads right here. As soon as we introduce the loads right here, it will be as simple as that. We can just make it a diode load just like that, and then just let me get a live load. Just make sure it's LL1. Okay, just make an add. I'm just not good with the dead load. My dead load should be different from the actual dead load, so I can say just hit FC and just make an add. Let's close it up. Let's go to load definitions. No, just not load definitions right now. I can go with the load manual combinations. Okay, this is combination 1. I can see it. Okay, combination to make it like ultimate. Okay, okay, 1.2 or 1.4 or 1.7, I don't know, it's confusing. Okay, 1.2 plus 1.6, I can go with that. 1.2, we can just go there, and with 1.6, that's not right. Right, it's like 1.2 right here and 1.6 right here. Just make an apply with that. Just make a new factor, and that should be working. Because if you see so much loads, then we can just make it at SLA serviceability load, working load. What happens here is we can just make a 1. You know, the serviceability load are without factors. That's good. Just make it comply and make it comply. Okay, now just go to the load definitions. First of all, dead load with the starting with the 0.6 level, and we can just go right here. No, okay, I think that's better. Then we can just surface. This is surface. We can just go with the surface load, which is the distributed load, surface distributed load, and the kilopascal. This should be understood that the kilopascal and the kilonewtons are the same thing. So what we have is we have already decided that we should make a dead load, because we need the calculations which should be complied with the hand calculations. So what is our dead load? Yeah, this is our dead load. Okay, dead load is 4.2 kilonewton. So it's minus 4.2 kilonewton. And I just make an add, and to add to where, just come here and we can see the floors, and the floors is like that. So it's very simple. You can just make it with that, As soon as your floor is near, it is gonna make it blink. Okay, this is 151. We can apply. This is dead load. Now we're going for live load. Okay, the live load for the ground floor. The live load, we know this, we have taken as -5. I know it's very large loads, but it's a commercial building. It's okay. I think it's fine. Okay. Now we can go for the second story here, and just select all the slabs from right here to here, and go for the live load. It's the same, and just make an apply. Then for the dead load, I'm gonna go here and just make sure that it is -4 point. How much it was? 4.2. Yeah, 4.2, and make an add with that. Yes, apply. Okay, we are good to go. You can see from here the numbers. Yeah, this is 4.2 and 4.3. Okay, now there's something I am missing here. You should go to the loads, load definition, and there should be a dead load of bar, and the bar load is no, the bar load is this one. Okay, so the bar load, how much is the bar load? Okay, you can make calculations. We have made it calculations for the bar loads. Okay, for the exterior walls it's 19.92. okay, it's quite too much. 19.92. How much is 19.92 for this one? For the exterior walls, I can go from here. Yeah, exterior walls. Okay, sorry. So we can add, click here, click on exterior walls. This is the beams we are going to carry the exterior walls. Okay, just make an apply. Yep. Go here. Same thing. Clear this up. Sorry. Actually, I can just go from the stories and stories number 2, and we can just go to the beams. I think so. That is a better idea. So I'm just trying to get synchronized. Okay. We can make an apply of that. That's cool. And going here, and we have the interior walls of a load of 16.32. We just make again 16.32 load of 16.32. Right. Add to the ground story level of from the top and select. Actually, all of the beams are not gonna be loaded that way, but just making assumptions. Alright. Apply. And that's it. This we are here, and walls. We are going to assume that all of the interior beams are going to be loaded with the blocks, so that way we can achieve a good section. Now our structure is completely fine. We can just close this up, and we can go for save right now. It's a good time to save. Now we have this one. Now we can go for this one. So we can just copy the stories. We can just go to here, structure. Sorry, there's sorry stories. Sign stories. I don't know where's copy stories. Just go here, just go like this and do like that. Two repetitions. Let's make here. Oh no. I know what has happened. I can just select this and make two repetitions. Just like 0, comma 0, comma 4. Right, that's right. Actually, the roof will not be loaded, so we can just come right here, and we can go for the load definitions.